Today our lesson 2 is talking about impulse. Before talking about impulse, let's revise the difference between momentum and inertia. Inertia is a property of mass that resists change in velocity. And inertia depends only on mass. So let's see here the difference between inertia and momentum. Inertia is a property of mass to resist a change in velocity. But momentum is a property of moving mass that resists changing in moving velocity. So inertia is a property of mass to change the velocity. And momentum is a property of the moving mass to change the velocity. Inertia is a scalar quantity. Momentum is a vector quantity. Inertia depends on mass. Momentum depends on mass and velocity. This is a difference between momentum and inertia. Is it clear now? So if I'm asking you what is the difference between momentum and inertia, you will tell me these three things. Inertia, yeah?
Yeah, it's clear.
Okay, so inertia is, it only scalar, but momentum is vector. Inertia depends on mass. Momentum depends on mass and velocity. The inertia is a property of mass to resist a change of velocity, but the momentum is a property of moving object to resist and change in velocity. This is just a revision between the difference between a momentum and inertia. Now, today we will talk about a change in momentum. Let's talk about a change in momentum. Now, Newton's second law states that the net external force acting on an object is equal to the time rate of change of the object's momentum. What does it mean? We know before that F net, Newton's second law, tells us that the F net is m times a. This is, we know it from Newton's second law. Now, we can also write it as m, and we know that the acceleration is a change in velocity over a change of time. Then we can also, we know yesterday that mv or m delta v, mv it's mean momentum, m delta v it's a change in momentum. Some books write momentum as a word momentum, and some of the other books write it as p. So p, it's mean momentum. Delta p, it's a change of momentum. So mv is a p. M delta v, it's a change of momentum. It's delta b over delta t. So he said now that an F net, or the net external force, equal to the net momentum, the change of momentum over the time. This is an Newton's second law. After its derivation, we will find that F net times delta t equal the change on momentum. If you make now a if you make now a cross multiplication here, we will find that a force times a change of time, times a change of time give me delta p. That means a change of momentum is a product of force times a change of time. So I have two formulas for a change of momentum. I have a change of momentum, I can write it as m mass times a change of velocity, and also a change of momentum, we can write it as a force times a change of time. This change of momentum, which is F times a change of time, we called it an impulse. So a change in momentum is an impulse. Now, momentum changes when a net force is applied, as we saw before. So here I have momentum. When it's change, when we have a change in momentum, that's mean when apply a force. All of us know that when there's an object is moving, like an inertia, the object stay at rest until there's a force acting on it to change its position. Also here, if there's a moving object and it's still moving, the car is still going. When it's change, when it's make a change, when it's stop, when you make a force. So when you apply a force on an object when it is moving, you make a change in momentum. And also, if there's you can say also if the momentum changes, if you see that there's a car that's moving and suddenly the car stops. Why? Because the force was applied to it. So if momentum changes quickly, that means there's a large force R involved. F delta T is equal to M delta V. I will repeat, MV is a momentum. Delta V is a change in momentum. So when you make a change of momentum, that means you make apply a force. Now, greater large of momentum, that means you apply a large force. Imagine it. When you are moving on a 60 kilometers per hour and you make a suddenly force stop, it's a large one, you will see that your body resists the changing. So that's when you have a high change of momentum. But if you want to stop one by one, second by second, you will find that the force that's involved is small, so the change of momentum will be small or will be less. Now before, but now here, until now, is there anything not clear?
No, it's all clear. Yeah, it's clear.
So momentum is a change. Change in momentum is an impulse. Now let's see now here, or I will repeat it. How can or from where they bring this formula? These concepts are merely our outgrowth of Newton's second law as discussed in an aerial unit. Newton's second law, which is FMA, states that the answer, you know what the Newton's second law said. So if you have now F is m times A, we know it before, or we carve it as m times delta V over delta T. This is how can we write a Newton's second law in another formula. Now, if both sides are multiplied by the quantity T, what did you get? You will get an F here. If you multiply by T, then you multiply by T, you will get that the force times time equal m times delta V. So this one, that a force multiplied by a time, this is, we called it impulse. An impulse is a force times the time, momentum. Momentum as a m times v. The delta momentum is m times delta v. So, and m times delta v, which is a change of momentum, it's an impulse. So, the F times the force times a time equals m times delta v. This is a change of momentum. This is an impulse. That's why a change of momentum equal impulse. So in physics, the quantity physics times the quantity force times time is known as impulse. Girls, please 1 minute. I will come. So in physics, the quantity force times time is known as impulse. And since the quantity m times v is the momentum, so m times delta v is a change of momentum. The equation really say that impulse is a change in momentum. Is it clear now?
Teacher, can you repeat the impulse again?
Okay, I will. Yeah, please. Is there a change? Here, I will repeat it in other words. By the way, I already said it before. Hello, we say that m times v is a momentum. This is we said it yesterday. Now, if I want to make a change in momentum, I can change mass or change velocity. Can I change the mass for the same object?
No.
No, we cannot change the mass. If the car is 20 kilogram, it will be 20 kilogram. So if I want to change the momentum, I will change the velocity. So a change in, I'm sorry for the disturbing, a change in momentum, that's mean I have to change a velocity. So change in momentum, it is m delta v. And also, we said that if we have an m a, or we carry it as m delta v over t, that's no big. Now ma is an Newton second law. Acceleration is a change in velocity over time. So I can write as m delta v over t. Let's make now a cross product here. F times t, you will get m delta v. Here I said that m delta v is also from here. We said that m delta v is the force times t. So I can write now m delta v as a force times t. That means also a change on momentum. So a change on momentum can be represented by m delta v or force times t. We have two formulas, a change on momentum. And sometimes you can say that the product of a force times the time is known as impulse. Is it clear?
Yes, thank you.
You are welcome. Now, then they told me that also. Now, if you want to make a change in momentum, okay, you can apply a large force. We said here that change in momentum, it has two formulas. M delta V and Ft. So if you want to make a change or a big change in momentum, you will make a large, or you'll apply a greater force. Apply a greater force, that means you make a big change in momentum. That's if you want to imagine it, as I told you, if you are in a car, the car is driving, or you are driving a car, I mean, and you make a force stop. That means you apply a large force on it. You will find that your body resists the changing of the moving object, so your change of momentum will be great. But if you want to stop rapidly, one by one, so you apply a small force, that's why your body will not moving fast when you want to stop suddenly. Did you imagine it?
Yes.
Okay. So the product of a force and the time, we called it an impulse, as we said before. Impulse is a way to measure a change in momentum, because it's not always possible to calculate force and time individually, since collisions happen so fast. So if I want to measure a change of momentum, either can I measure the difference in the velocity. That's, as an example, I'm working on 60, suddenly it comes as 0. So I can measure the change in velocity. It's easier for me to find the change of momentum. And sometimes I can measure the applying force to find a change of momentum. So sometimes when I can measure the force, I can find the change of momentum. If I find the change in velocity, I can find the change of momentum. So to find the change in momentum, I can find the change in velocity or the force. If the momentum of an object changes, here, I'm talking here about momentum, sorry. So if the momentum of the object change, either the mass or the velocity will be changed. Now, the greater the force acting on the object, the greater its change in velocity and a greater change in momentum. Here, as we said before, to make a change in momentum, I can make a change in mass and a change in velocity. But since I cannot make a change in mass, so that means greater force apply, greater change on velocity, that's equal also F times T. So greater force apply, that's mean greater change of velocity, that's mean greater momentum. Greater force, greater change of velocity, that's mean greater momentum. When you...
Teacher, is this what they call the impulse momentum theorem?
Yes. Impulse momentum. So here, I will come back to the car. You are in the car. You want to stop suddenly, so you apply greater force. When you apply greater force, that means you are in 60 60 kilometer per hour, and when you apply a force, suddenly you come to 0. So this greater change, because of force, it's make a greater change of momentum. But if you apply a small force that you are on 60, then you comes on 50. So you have a small magnitude of change on velocity. So you have a small change of momentum. Is it clear?
Yes.
Okay. Now, a force sustained for a long time produces more change in momentum than does the same force applied briefly. So, let's come back now. So we said now that a change of momentum by m delta v. So by changing the velocity, this is the first way to change the momentum. And also we say that a change of momentum is f times a change in time, or f times time. So to make a change of momentum, we can make a change also, or if you have a greater change in time. So if you the force apply the same force applied on a car which is moving for a long time, that means you will make a greater change of momentum. So increasing, if the delta t is greater, if you have a long time, so you will make also the change of momentum will be great. And also, if the force that is applied is great, as we said before, the change of momentum will be great. So to change the momentum, you have to change the velocity, or apply for a long of time, or you have a greater force. This is a way to change the momentum. When you push with the same force for twice the time, you impart twice the impulse, and so you produce twice the change in momentum. So if you make here, you say now, like an impulse is an f delta t. So when you twice the t, when you apply it with a long of time, so you will twice an impulse, so you will twice a change of momentum. So let's repeat. To change the momentum, you have to change delta v, or you have to change the duration of time, and you have to change the force. This is if you want to change the momentum. Now, if you want to apply, or you want to twice a time, so we say that f t is impulse, and impulse is a change of momentum. So twice a time, that's mean twice an impulse, that's mean twice a change of momentum. Is it clear?
Yes.
Okay.
Teacher,
Let's have, yes.
teacher, can you just write the formula for the impulse, like just explain both the ways of the formula?
Sorry, repeat.
Can you repeat the formula of the impulse? Just the formula.
F times t.
Yeah, like how it's working like that.
Is it on this slide or before?
Before, I think.
This one here?
Yes, this one. Just the impulse formula.
Okay.
Thank you.
You're welcome. I will repeat it here because here I have space. Now, Let's start. Yesterday, as you remembered, I told you we revised the Newton third laws. Why? Because to remind you that the Newton second law, which is a product of mass times acceleration. And we know that from the Newton first law, what is the acceleration? It is a change in velocity over time. Is it right? Yes, Rose, is it right?
Yeah.
Rose, are you here?
Teacher, can you hear me?
Yeah. I told you that from Newton's second law, we say that a force is m times a. And from Newton's first law, we know that the acceleration is a change of velocity over time.
Yeah.
This one here, okay? And we keep m as it is. Then, so here what did we have? We have m equal m delta v over t. I write it or I simplify it in math. Making cross product, what did you have? Force times time.
Can I answer?
Equals m delta v. Is it right, Rose?
Yes, teacher.
Here you make a cross product. Now, m delta v is what? Is a change?
A change in the
Momentum. A change of momentum is, we name it with impulse. So the formula of impulse is F times T. That's what you want?
Yeah.
Okay.
Okay, teacher. Thank you so much.
You are welcome. Now here. Yes, Haneen. Haneen or Susan asked me to solve. Or
Haneen.
she said, teacher, can I say?
Yeah, it's me, Haneen.
Haneen, yes, Haneen. If the halfback experienced a force of 800 Newton, so the force here is 800 for a time of 0.9 seconds. Now, to the north, determine the impulse. What is the impulse here?
Force times time, so it's 800 times 0.9.
So it is a force, a product of force times time. Force is 800, a time is 0.9.
So it's
9
700
times 8 is 72. 0. Take 0 from here. It is 720. Now, what's the unit?
No, it's only 1 0.
Sorry?
Yeah.
Now let's talk about the unit here. What is the unit of force?
Newton.
Newton. And time?
Seconds.
Second. So the unit for impulse is 720. The new unit for impulse is Newton second.
Teacher, what about the unit for momentum?
Momentum, it is kilogram. Later on, I will tell you about them here. Here I make a difference between them. And in impulse is a Newton second, and momentum is kilogram meter per second. This is a difference between them. Impulse is a Newton second, and momentum is kilogram meter per second.
Yeah, because I always confuse their units.
That is no problem. Now, this one here. A 0.1 kilogram model rocket's engine is designed to deliver an impulse of 6 Newton seconds. So here I have a mass, 0.1. Here I have an impulse. Let's name it with I, or we can write it as impulse here, as 6. If the rocket engine burns for 0.75 seconds, so the time is 0.75. What is the average force does the engine produce? Here, I want to find a force. Here I have an
Can I say
impulse.
what?
Yes, Rose.
It is F force times time equal m times 2
Yes, so here F times T. They asked me about the force. The force is unknown. What about the time?
and the time is
0.75.
0.75. And the impulse?
and
6.
6, exactly. Over 0.75 over 0.75. So a force is 6 divided by 3 over 4, or 6 multiplied by 4 over 3, which is 8 Newton. This is how to find a force. Now, let's have another example here. A bullet traveling at 500 meters per second is brought to rest by an impulse of 50 Newton second. So here we have a change of velocity 500 meters per second, and an impulse. Now some of the box write them as J, some of the box I, some of the box keep it as impulse. So J here is 50 Newton second. I have an impulse and I have a velocity. They asked me to find the mass. I have a velocity, I want to find the mass, and I have an impulse. Now, let's solving it here. Wait.
Teacher, is it J? It is impulse.
Yes. Some of the box, as I told you, they make them as yeah. So here the velocity. Oh, sorry. So here the velocity is 500. The impulse here is 50. They ask me now to find the mass. Okay, we say that an impulse or a change in velocity, it has two formulas, Ft or m delta v. Okay, since I have a velocity and since I want to find the mass, so I have to use the second one. So impulse is m delta v. Okay, so because of that now, what's this here? So impulse is for mv. So the mass is unknown. Now, a bullet traveling at 500 is brought to rest. So for the v, as we know before, we have v final and v initial. Delta v is v final minus v initial. What is the v final here? He is traveling at 500 is brought to rest. So we have a change, which will be 500 minus 0 equals an impulse. Impulse is 50. So m 500 times 500, sorry, is 50. So what the mass will be?
Divide by 500.
Yeah, which is
Teacher?
0.1 kilogram. Yes, miss.
V final, isn't it 0? The V final?
Yes, but the change, it must be positive.
So you make it 500 minus 0.
Yeah.
Okay.
Is it clear?
Yes, teacher.
Yes.
Now, unfortunately, I have only 2 minutes left. I will try here. Now here, just to make a difference, or to revise an impulse and momentum. Momentum is the product of mass and velocity. Momentum is a resistance to stop. It's a kind of inertia, as we said yesterday. Impulse is a product of force by the time, which is a change in momentum. Hitting a baseball with bite, a force will change the ball's direction, change the velocity and the momentum. So, as we said, change a force or apply a force, you will change the velocity, so you will change a momentum. This is for the definition between, or difference between momentum and impulse. Impulse is a change of momentum. Momentum is a mass times velocity. Impulse is a force times t, or m times delta v. Impulse, its unit is a Newton second. Momentum, its unit is kilogram meter per second. Momentum, its formula is m times v. Impulse, its formula is F times t, force times time. And here you have mathematical problems for it. If you have a 40 meter per second, 2 kilogram velocity, mass, you multiply them, you will get momentum. If you have here a force with applying time, so 3,000 or 30,000 Newton times second, you will get an impulse. So the unit of momentum is a kilogram meter per second, and the unit of impulse is Newton second. Is it clear?